Hi everyone, here is a short video that is going to demonstrate 3 problems off of the 8.4 word problem worksheet. The problems that I chose is number 1, 4, and 5. So starting out with number 1, radio towers. K is standing near a 200-foot high radio tower. Presumably, I guess this is K. And use the information in the figure to determine how far K is from the top of the tower, so they're looking for that question mark or the hypotenuse. But they want you to express your answer as a trigonometric function. That's why I chose this problem. I think at this point by now, most of you could find that length, but they specifically asked you to express it as a trig function, so I wanted to point out the difference. Okay, as always, SOHCAHTOA. And if you look at where K is standing, the angle of elevation here is 49 degrees, and the 200 high-foot tower represents the opposite side from that angle, and we're looking for the hypotenuse. So we've got opposite and hypotenuse, and at this point you should see that we're looking at the sine function. Alright, so the sine of a given angle, we know the angle. So we're going to take the regular sine function is the opposite divided by the hypotenuse. The sine of 49 degrees equals 200 divided by the hypotenuse, which in this case I just named x. Now if we cross multiply, we're looking for x, that distance, and we want to represent it as a trig function. So we're going to cross multiply that up, and we have x times the sine of 49 degrees equals 200, and we're trying to solve for x. We want to isolate x, and x is currently being multiplied by the sine of 49 degrees, so we're going to divide by the sine of 49 degrees, and whatever we do on one side of the equal sign we have to do on the other. And so we get these canceled, and we have x equals 200 divided by the sine of 49 degrees. Now if the problem asked you to find the actual length, you would go ahead and use your calculator to figure this length out. We might as well do that, but the answer here that they were looking for is 200 divided by sine of 49 degrees, leaving your answer in the form of a trig function. But if we did want to find that actual length, we could, and we could use our calculator to say 200 divided by and I get actually exactly 265 feet. Okay, next. Problem number 4, I chose this problem because it's asking about angles on the coordinate plane, and as you know, all year I've been saying we really don't know much about angles on the coordinate plane until we understand trigonometry, and now is that time. So here we have line M, and if it's not obvious from the question, it's asking what is the angle that the line M is making here, and that angle I believe is here. They're looking for the angle between line M and the x-axis. So here, up until now we wouldn't know how to do that, but in this case we can actually look where line M crosses or intersects perfectly on the grid and get some side lengths. So here we've got an opposite side of 2, and we can count the boxes and get a side here of 6. So, SOHCAHTOA, we know the opposite and the adjacent, so we are looking here at the tangent. So the tangent of an angle equals the opposite over adjacent, and in this case we don't know what that angle is, so we're going to be taking the inverse function whenever we want to solve for the angles. We've got the inverse tangent. I don't like my handwriting there. The inverse tangent of the ratio is going to give us back theta. So the inverse tangent of 2 divided by 6 equals theta. Again, I've said this in other videos. I let the calculator do the work for me. I don't divide 2 by 6 and get 0.33333 and then plug in that into the calculator. I just take 2 divided by 6 and I let the calculator do the work for me. That way I know I'm going to get my most accurate answer. So I get 18.43 degrees for theta. I think it's important to note at this time, I mean, we're not going to be working on this too much this year, but next year in your new course, do you see any relationship here? This tangent of theta, the tangent of that angle there, is very interesting. It's the opposite over the adjacent, and I wonder if you see a relationship there. It's actually the slope. It's the rise over the run of that line M. So that's a very interesting relationship there. Okay. Next, many of you specifically requested this question. I think the wording maybe tripped up some people in understanding. So hopefully this isn't getting cut off too much. All right, number 5, the neighbors. Amy, Barry, Chris live on the same block. Chris lives up the street, and around the corner from Amy and Barry lives at the corner between Amy and Chris. The 3 homes are the vertices of the right triangle. So instead of using, these names, I just use A, B, and C. Give 2 trig expressions for the ratio of Barry's distance from Amy. So Barry to Amy would be BA. So we're looking for the ratio BA to Amy to Chris's distance, or Chris's distance from Amy. So that would be CA. All right, so we're looking for 2 ways to express that ratio. Well, CA, regardless of what angle we're looking at here, what acute angle we'd be looking at, CA is the hypotenuse. So if we look at SOHCAHTOA, and we know we've got the hypotenuse in play here, the 2 different ratios we're going to be looking at are the sine and the cosine. So from the perspective of the 64 degrees, if we look up here, the 64 degrees, we've got BA is the opposite. So from the perspective of the 64 degrees, I'm going to write this down, BA is the opposite. So we can say 1 trig ratio here from using the 64 would be the opposite over hypotenuse or the sine. So the sine of 64 degrees here is definitely going to represent BA over CA. Now, let's look at it from the perspective of the 26, oops, not 36, 26, from the 26 degrees. What is BA over CA? Well, we said CA, no matter what, is the hypotenuse. BA, from the perspective of the 26 degrees, is the adjacent. So hopefully you can see that we're looking at the cosine, and the cosine of 26 degrees is equal to the same ratio, BA over CA. So the 2 answers that we're looking for is sine of 64 degrees and the cosine of 26 degrees. Okay, question B. Give 2 trig expressions for the ratio of Barry's distance from Chris. So we're looking at BC and the ratio of BC to Amy's distance to Chris, or AC. All right, so BC is over here, and AC again is the hypotenuse. So let's look at it from so no matter what, AC is the hypotenuse. So hopefully you can see that we're also looking at cosine and sine again, but this time let's look at BC as the numerator instead of BA. So from the perspective of the 64 degrees, what is BC? From 64 degrees, BC is the adjacent. So we can represent the adjacent over the hypotenuse as cosine of 64 degrees is going to equal BC over AC. Now let's look at it from the perspective of the other acute angle, 26 degrees. From the perspective of 26 degrees, BC is the opposite, and AC, of course, is the hypotenuse. So in this case, we have the opposite over hypotenuse is the sine. So from the perspective of the 26 degrees, sine of 26 does equal BC over AC. So our two trig functions that represent this ratio is sine of 26 degrees and cosine of 64 degrees. And finally, the last question here, C, give a trig expression for the ratio of Amy's distance to Barry, that's AB, and that ratio, AB to Chris's distance from Barry, so that's CB. So taking a look up here in our drawing, AB is here, and CB is here. And so we've got our choice here. We could, actually it asked for 1, not for 2, but we might as well list 2. AB from the perspective of 64 degrees is the opposite, and CB from the perspective of 64 degrees is the adjacent. So we have the tangent of 64 degrees equals AB over CB. And then our answer here would be the tangent of 64 degrees. Hope this helps.